Hello, a new session today. Let's consider this curve y equals function x and then within the range a to b. Now you can see I have highlighted the area under the curve, and now we want to revolve this plane figure about the x-axis to form a 3D figure. Then just imagine the figure that you can form this one. And please note that the revolution is a complete revolution. And now I'm going to do a simple proof to tell you how to find out the volume of this 3D figure. Now we are going to cut this 3D figure into slices, and we just take out one. And you can see this slice is a cylinder. Therefore, the volume is the base area times the height. And now let's look at the height. That means this is the thickness of this figure. And you can see this part actually it lies on the x-axis. Therefore, we can simply say this is dx or delta x, up to you. Okay, now the base is a circle. Therefore, we need to find out its radius. And if you look back the curve, you can see the radius actually is the value of y. Therefore, the volume of this part equals to pi y squared and then times dx. And remember, there are many slices for this 3D figure, and integration can help us to sum up all these small parts. Therefore, the total volume equals to the volume of one slice and then sum up from A to B. And of course, for the constant pi, you can take it out. Therefore, you can see the volume is you take integration for the curve square within A to B and then times pi. And please note that this formula is for a complete revolution about the x-axis. Okay, later we will talk about the case for a revolution about the y-axis. And one more thing, if you look at this part, that means this slice, it looks like this. Therefore, this method is called the this method. Let's do a simple example. Now in the figure, the region bounded by the curve y equals x to the power 3, x-axis and the line x equals 2. That means that the shaped region is revolved about the x-axis. Find the volume of the solid of revolution. We call the formula for finding the volume of it, and since we want to revolve that about the x-axis, therefore must be in dx, and inside it should be a function, okay, in terms of x, even it is y squared. That means y equals something. Now let's start. So the volume equals to pi times, take integration from 0 to 2, and y squared. Now y is x to the power 3, so you take square for it and then dx. And expand it, you can get x to the power of 6, then take integration, therefore it becomes this one. Then by substitution, you can get the answer be 128 pi over 7. Done. Now let's look at the second example. Again, we want to find out the volume of the solid, but this time a bit different. That is, we want to revolve the figure about the x-axis by 180 degrees first. That means not a complete revolution. So we just apply the formula first, and we want to integrate, okay, for the curve from x equals -2 to 2, because we want to use dx at the back. So the upper limit and the lower limit must be the values of x. Now the function inside, which is y squared, therefore we need to change this curve to y first. But luckily, we need y squared, therefore we don't need to take any square roots for it. So the function inside will be 1 minus x squared over 4, and bracket is okay. But since this is not a complete revolution, therefore we need to multiply 180 degrees over 360 degrees. That is half of it. And just do it as usual. And I forgot to take the pi. for the volume. Therefore, add the pi here. Okay, and then add the pi here. And after that, you can get the answer be 4 pi over 3. Done. Another example. And sometimes we can use this technique to derive the formula for volume of some common figures. Now for this one, a straight line is given, and now we want to revolve this one, and then about the x-axis, so that you can form a right circular cone. And now we are going to prove that the volume is 1/3 pi r square h. So just apply the formula, the volume equals to pi, and then take integration, okay? And now we need to use dx at the back. So the upper limit and the lower limit are all values of x, which is from 0 to h. But for this problem, the equation of the straight line is not given, therefore we need to find it out. Now please note that the vertical distance is r, the horizontal is h, therefore the slope is r over h. Then, and by y equals mx plus c, and since the straight line passed through the origin, therefore c equals 0. Therefore, we can get the equation of the straight line be y equals r over h times x. So put it inside the integrals, you need to take square of it. Therefore, r over h and then x square. As r and h are constants, therefore I take it out. Therefore, only x squared inside the integral. So we can get the volume of a right circular cone be 1/3 pi r square h. Done. So far, we have done 3 examples about the revolution about the x-axis. Now, let's do one case for y-axis. First of all, let's imagine the figure that you revolve. It becomes this one on the right hand side. Also, by the same method, we can prove that for the volume about the revolution about the y-axis, it should be pi, also pi, and then within the range a to b, and then dy this time. Therefore, inside it should be x squared, but not y squared. The idea is the same. Just cut it into slices, and then take out one slice, and then try to find out the volume of it, and then take integration. You may try it. So let's do it together. Therefore, the volume equals to pi times, now write down dy first. Therefore, the upper limit and the lower limit must be values of y. That means from 0 to 1. Now, inside the integral, it should be x squared. And luckily, x is the subject of this curve. Therefore, y times e to the power of y and take square. And then expand it. You can get this one, and you find that it is not easy to find the integrals of this one. Therefore, we need to apply the technique of integration by parts. After that, you can get this one. And don't forget to times pi for both parts. And next, we can cancel 2 for the second integral. And it seems that we need to apply the integration by parts again. So you can get the next line. And for the last line, just want you to pay attention to this one since we want to minus the whole integral. And then for this part, we need to take integration by parts. Therefore, it becomes plus here. And then we can directly integrate the final integrals so that it becomes this line. And finally, you can see these 2 terms can be cancelled. So it becomes pi times e squared over 4. And then minus, the next one is not 0, because e to the power of 0, that is 1. Therefore, minus pi over 4. And of course, if there are 2 fractions, let's combine them. And then take out the common factor pi, so it becomes this one. Finish. And from this example, you can see the difference between revolution about the x-axis and about the y-axis is the first one. About the y-axis, that is dy. About the x-axis, that is dx. And inside the integral, if it is dy, then we use x squared. But x squared is in terms of y. Okay? And the others remains unchanged. The next case, we are going to consider the case about the revolution about a horizontal line, but not the x-axis. So just imagine how to revolve this figure, and you can see we can form this solid figure on the right hand side. And now it is quite similar to the case for x-axis. Therefore, we write down the volume and then it equals pi also. After that, pi times take integration, and at the back it should be dx because it is a horizontal line similar to x-axis. We use dx at the back. For the function inside, we always use the curve minus the axis of revolution. In this case, that is y equals 4, therefore minus 4. And of course, take square for it. But just want to remind you that for area, we must use the upper one minus the bottom one. Now, let's find out the upper limit and the lower limit. Since it is dx at the back, therefore, both of them must be the values of x. But now you can see, look at the endpoints. We get this one 0, right? But we don't know the x coordinate of this point. Therefore, we need to find it out. And you can see this point actually is the point of intersection between the curve y equals 4 and y equals root x. So before we find out the volume, we need to solve these two equations first. So you can write it in this way. And after that, you can get root x equals 4 and x equals 16. Therefore, the upper limit is 16. After that, expand the function inside and then take integration for each part so that you can get this line. Then do substitution and substitute x equals 16, you can get this 3 times. And for the second part, you put x equals 0, all of them are 0. So that's the answer. So after that, by calculator, you can get the answer be 128 over 3 pi. You don't need to type the value of pi. Okay, just keep the exact form, it's okay. The last example. Now we want to find out the volume of the solid generated by revolving the region bounded by this curve, this straight line, and the x-axis. About this line, it is a vertical line. Therefore, we better sketch the diagram. First of all, I will draw the straight line, the vertical line, x equals 5 over 2. That means here. And then next one is the x-axis, that means this horizontal line. And the last one should be the curve, x equals to 1 over 2, y to the power 3 plus 2. But it's very difficult for us to get the exact shape of this one. Now look at the graph. I highlight the x-axis, the vertical line, and now the curve. We want to know the approximate location of this curve. So I will put y equals 0. That means I want to find out the x-intercepts of this curve. And when y equals 0, x equals 2. Therefore, I can mark a point here, which is 2. So in order to form an area bounded by these 3 parts, the curve will go like this. Maybe it is concave upward, maybe it is concave downward, it doesn't matter. Now, we can form the shaped region like this. And now we want to revolve this figure about the line x equals 5 over 2. That means like this. So just imagine you can form the 3D figure below. And one more thing, when x is larger than 2, we know that y must be positive. Therefore, we can draw the curve like this. And please note that this time, the axis of revolution is a vertical line. That means similar to the case of the y-axis. Therefore, we can say the volume equals to pi times, okay, take integration, and y-axis, that means dy. You can remember it like this. And the function inside should be in terms of y. Now, we will use the curve, which is 1 over 2 times y to the power 3, and then plus 2 minus the axis of revolution, that is 5 over 2, and take square. Next, we need to find out the upper limit and the lower limit. Since it is dy, therefore, they are the values of y. Now look at the endpoints. this point, we know the value of y is 0. Therefore, write down the lower limit as 0. Next one, the endpoint is here and here. Now, do we know the y values of these 2 points? No. Therefore, we need to find it. And look at the point at the top. It is the point of intersection between these 2 curves. So just solve the 2 equations and you will get y equals 1. Therefore, the upper limit for the volume, this part is 1. Next, try to simplify the function inside so that you can get this one. Next, I will expand it and then take integration as usual. And finally, you can get the answer be 9 pi over 56. Finish. To summarize, there are 4 different cases for this part. The first one, revolution about the x-axis. Second one, y-axis. The third one, horizontal line. And the fourth one, vertical line. And for point 1 and point 3, as they are horizontal lines, therefore, we will in and then dx at the back. And for point 2 and point 4, since they are vertical lines, therefore we will in and then dy at the back. Homework time. And as this is part 1 of 14.2 only, and so all of them are level 1 problems. Okay, homework A, 7 questions, and homework B, 8 questions. And the deadline is this Saturday, not Friday this time. Okay, give you 1 more day. And for the second part of 14.2, I will teach you after school resumes. And I think this one will be the last video. So see you next time face to face. Goodbye.